Welcome to this explainer. You know, when we think of bananas, we usually just picture a quick snack, right? But the stalks left behind are actually this incredible, completely untapped source of natural fibers for sustainable textiles. Today, we're unpacking the fascinating and rapidly escalating journey of extracting those fibers. We're going to start with the simplest, most natural processes out there and work our way all the way up to intense, high-pressure engineering.
Okay, let's look at our roadmap. We'll be covering four main extraction methods: retting, the mechanical process, the chemical process, and finally, the steam explosion process. Notice how each step ramps up significantly in complexity.
All right, Section 1, retting. Let's start with the most basic, nature-driven method available.
So, what exactly is retting? Basically, it's all about breaking down the natural glue that holds the banana stalk together. You've got these incredibly useful fiber bundles inside, but they're literally bound to the cortex by complex organic polymers, specifically lignin and hemicellulose. To get to the good stuff, we have to break down that glue.
This whole thing happens in two pretty gentle, natural stages. First up is the physical soaking phase. The stalk just absorbs water, swells up, and that naturally pulls out some of the easily soluble substances. Simple enough. But then comes the microbial stage, and this is where nature's microscopic workforce really steps in. Depending on the exact environment, you've got either aerobic or anaerobic fungi or bacteria doing the heavy lifting. They're essentially eating away at that remaining lignin and hemicellulose until the fibers are completely freed up.
Moving right along, Section 2 is the mechanical process. Let's see how we transition from slow, natural decay to raw, physical force.
So here we totally ditch the bacteria and just rely on mechanical power. The raw stalks get fed into a dedicated machine where fixed and high-speed rotating knives literally smash and break down the material. It's violent, but it works. That sheer physical impact rips the usable fibers away, dropping them right onto a conveyor belt to be washed and dried. It's fast, it's forceful, and it completely skips that massive wait time of natural retting.
Next up is Section 3, the chemical process. This tackles exactly what that mechanical force sometimes leaves behind.
Now, even after you mechanically separate them, those fibers can still be coated in stubborn stuff, hemicellulose, natural oils, and waxes. And this is where the chemistry comes in. The really interesting thing our source points out is that these leftover impurities are fundamentally acidic. So what's the fix? You boil the fibers for about 30 to 60 minutes in mild alkalis, like soap or sodium carbonate. That completely neutralizes the acidic impurities and just strips them right off the fiber's surface.
Whether you're using water and bacteria, rotating knives, or an alkaline boil, these first three methods are basically foundational. They're setting the stage for what is, hands down, the most complex, intensive extraction technique on our list. And that brings us to Section 4, the steam explosion process. The sheer scale of the thermal and chemical engineering involved here is wild.
We start with what's called fast-frying steam extraction. Picture this. You take a massive 20-kilogram fresh banana stalk, seal it up tight, and blast it with steam pressure at 1.40 megapascals for exactly 100 seconds. Then, boom, you abruptly release that immense pressure, wash it, dry it, and you are left with just 660 grams of raw fiber. I mean, wow, that is a remarkably low 3.3% yield. It really puts into perspective just how much water and non-fibrous mass is locked up inside those raw stalks.
But wait, we're not done. To refine that tiny yield, the fiber goes through a really rigorous 30-hour soak. The raw fibers are completely submerged in a highly specific sodium hydroxide solution right at room temperature, and then they're repeatedly washed until they are chemically neutral.
Right after that epic soak comes vapor exploding degumming. And it's exactly as intense as it sounds. The fibers go right back into the steam explosion jar. They get pressurized again at 1.40 megapascals for 120 seconds, and then another abrupt release. That massive sudden drop in pressure literally explodes the remaining gums and impurities right off the fiber structure, amazingly without destroying the actual fiber itself. Next, we have this highly precise two-stage bleaching process. In Stage 1, the fibers sit at 58 degrees Celsius for 2 hours, and the process relies mostly on sodium hydroxide and hydrogen peroxide. But then, look at the shift in Stage 2. The temperature gets dialed up to 65 degrees, and the chemical ratios totally change. We drop the peroxide and bump up the sodium silicate. It's this incredibly intricate chemical dance designed to achieve absolute maximum purity.
Finally, we reach the home stretch, post-processing.
These beautifully bleached fibers are treated with a bit of oil to bring back their flexibility, then they're dried, cut, and run through a carding machine to untangle the whole shebang. And those final steps give us the ultimate prize, pure, white, commercially viable banana fibers.
All of that, the crushing pressure, the 30-hour soaking, the explosive depressurization, it gives us some highly specific, incredible specs. We're talking fibers 140 millimeters long, an awesome breaking strength of 3.2 grams per denier, and the residual gum is stripped all the way down to a mere 3.9%. These numbers are crucial because they mathematically prove this fiber is completely ready for demanding commercial textiles.